All right, thanks, guys. So you guys just heard my name. My name's Neil. But for the show, you can go ahead and call me Dr. Cosmos. Now, before I get started, there are three things I want to cover. The first one is stuff on this table is either fragile, dangerous, or expensive. So unless I tell you to, please don't touch it. The second thing is sometimes during the show, we're probably going to get kind of loud. And if I think we're getting too loud or I need to bring us back on track, I'm going to clap a rhythm, and I want you guys to clap it back at me. So I'll do a practice round right here. I'll go. Oh, you guys are superstars at that. All right, and the third rule, which is really easy, I want you guys to have fun with this. All right, so while my volunteers are getting their animal costumes on, I want us to focus our attention over to the cave. Now, some of you may say this isn't a cave, but I would say you are wrong. This cave, if you may be able to see this, hopefully you can, has some white balls on the top and some white balls on the bottom. Now, those represent stalactites and stalagmites, which you find in caves, which are rocks that form over really long periods of time for water dripping down from the ceiling and then evaporating and leaving the minerals behind. If you have any questions, I can answer them at the end of the show. Thank you. All right, so these things right there, that one little layer, if that were to form in nature, that would take about 500 years for each one of those. So these types of things form over really, really long periods of time. But we don't have that kind of time, so we're going to have to speed up the process a little bit. So I'm going to need two people to come up and help me build this a little bit. So I'll take you, and I'll take you right there. All right. Now what I need you to do, if you look, you'll see there are 9 on the bottom and 9 on the top. And each one of these balls has 2 different types of Velcro, that kind and the fuzzy kind. I want you to take the grabby kind and just kind of stick it right on top of all of those. So there's 9 on top and then 9 on bottom. All right. So while my volunteers are kind of building up my stalactites and stalagmites, I want us to draw the attention over to the worm. Now, this worm is a very common animal that if you find underground. Worms move through the ground by kind of wiggling. So why don't you show me what a worm wiggling through the ground would look like? Oh, that's good. All right. Now, when they move, they have a lot of help from these hairs that cover their entire body called setae. And they help them push through the ground and kind of displace a lot of the dirt. But they still have the problem of the dirt right in front of their face. So the way they solve that problem is they eat it, and then they poop it back out the other end. And when they do this, their poop is really high in something called nitrogen, which is something that helps plants grow, which is why people tell you worms are really good for the soil, because they help plants grow a lot. I have a question. Where's my mole? All right, who wants to be my mole?
And the mole is this big.
All right, you are my mole. Get on over there. All right. So while the mole's getting situated, I want us to draw the attention to the prairie dog. You're good, you can just stand up. All right, so prairie dogs are the most social of the animals I'm going to be talking about. Unlike the worm and the mole, the prairie dogs live in towns. In fact, they live with about 1,000 other prairie dogs. And they have a very complicated language. Those are actually hands. They have a language in the same way that we do. They can give different type of chirps and different type of barks. And this helps them to talk to each other. They have different words for water and food and different types of danger, like snakes and eagles and bears or whatever. So you have a lot of predators that eat you. So you've gotten really good at identifying them and talking to each other and saying when you need to get away. So what I need you to do is, first of all, you got to complete your costume and get your nice prairie dog nose on. Just like that. Adorable.
What is that?
So what I need you to do is give me some prairie dog chirps and barks. Prairie dogs, the noise they kind of make is like a high-pitched yipping noise. So like yip, yip, yip. Burp, burp, burp. You want to give some for me? Okay. Well, it seems our volunteer's a little shy, and that's okay. You guys kind of got an idea of what they might sound like if from what I did. You guys can actually, why don't we have you guys do it? Why doesn't everyone in the room kind of give me what they think a prairie dog should sound like? All right, kind of yip, yip. Now your turn. All right, good job. So if we were in a prairie dog colony, it would probably sound a lot like that. There would be a lot of different prairie dogs yipping at each other and talking and discussing things that they find and things that they see. So now I want us to draw our attention to the mole, who is just about ready to go. Now, the mole is a relatively common animal in North America, and their primary diet, those go on the hands, is our worm here. A mole can eat probably about 1,000 worms in one day, and they do this every day. And worms are pretty much the main part of their diet. They eat other things, but worms are the staple of their diet. And so who here has seen a molehill in the ground? Looks like a lot. It's the raised dirt mound in your ground. Adults, you may know this is the animal that destroys your lawn. Thank you for that, by the way. So these animals, they dig those holes at about a rate of 10 to 15 feet every hour, all day, every day. And that's why they break your lawn so bad. And they come out only at night, and when they come out, they look for types of food that aren't worms, and they try to mate and things like that, which is why they like to walk around. So what I need you to do is I need you to dig across stage. Kind of give me some digging action and move across stage. Oh, excellent. So, as you may notice, she's wearing some very stylish glasses and some nose and some very pink gloves. Now that's to show you that these moles have a very sensitive sense of touch, a very sensitive sense of smell, and absolutely terrible eyesight. And the reason they have this is because they spend most of their time underground, so they've had to find other ways to adapt and do really well under there. So let's say she's digging a tunnel, and then suddenly a worm falls down behind her. What she'll do is she'll turn around, grab the worm, and eat it. You do that for me? Just grab the worm and eat it. All right. And she can do that all under half a second. She can feel when the worm falls, turn around, grab it, and eat it all under half a second, which is faster than we can see it as people. That's a pretty quick reflex you have there. Quicker than I would want to eat a worm. All right, so why don't we give a big round of applause to my animal volunteers. You guys can go get those costumes off. Thank you for being such great sports. Can you be over there? Thank you. All right, so those are just some of the animals you might find underground, and I've talked a little bit about the caves, which are just structures underground, but I haven't talked too much about the ground itself. And I'm going to start by going very, very deep in the ground, all the way to the center of the Earth, the core, which creates a really big magnetic field that surrounds the entire Earth. Who here knows what a magnet is? All right, looks like most of you know. You can use these to pick up paper clips. They kind of draw metals into them. And you can use these magnetic fields to do a whole lot of things. So for example, who knows what this is? Why don't you guys just shout it out? Metal detector! You guys are absolutely right. As the name suggests, it can... Thank you. This is a metal detector, and as the name suggests, it can detect metal. So what I have here are 6 mystery bags, and each one of these bags contains an item. 3 of those items are metal, 3 of them are not metal. And I need 6 people to come up here and scan these bags, and whatever you find in the bag, you're going to get to keep. All right, so I'll take you and you and you right there, her in the dress, you in the back, you in the way back, yes you, and you in the yellow right there. Okay. So to give you an idea of what will happen if you do scan metal, I'll start off by scanning this metal thing right here so you can hear the noise it'll make. All right, so confirmed that is metal. What I'm going to need is I'm going to need you guys to form a line. You are first in line. Everyone get behind him that way. What I need you to do is point at and don't touch which bag you want to scan. This is always the first bag they pick. I think it's because the biggest one, and everyone wants the biggest thing. It's not the best thing, by the way. All right. So also, a side note, if this rotates, it goes off, meaning when you hold a metal detector, you have to make sure that part doesn't rotate. All right, so here we go. Is there metal in there? Yeah? All right, I want you to reach in there and describe to me what it is that you found. Be as descriptive as possible.
Sticky.
Sticky? Shouldn't be.
Kind of.
All right, and what is that?
It has a nickel on it.
Okay, so it's a bug. It's a beetle with a nickel taped on top. That's an excellent find. You can go ahead and take a seat. Thanks for coming up. All right, so now you point. Okay, this one? All right, let's give it a scan. So we scan. Is there metal in here? You are absolutely right. Reach in and tell me what it is that you found.
A yo-yo.
It is a yo-yo. Good job. It's an American flag yo-yo because that's how I roll. All right. So now we scan this bag and we discover, is there any metal in here? There's not. Reach in and tell me what it is you found.
Paper?
Kind of. It's a sticker for mad science because you can never promote yourself enough. All right, your turn. That one? All right, let's give it a scan. Also non-metallic. Reach in, tell me what it is.
Another sticker.
Another sticker. I think I'm seeing a pattern here on the non-metallic items. All right. And you scan. And we find something non-metallic. It's probably a sticker. It's a sticker. Congratulations. All right, and you are left with this bag because it's the last one left. Grab the metal detector. And let's give it a scan. Metal in here? Yeah, there is. All right, reach in and tell me what you found. There's 3 of them. Those are buttons that have inspirational sayings like be kind and things like that, because being kind is a good thing. All right, so I want to give our volunteers a big round of applause for coming up here. All right, so I talked about the center of the Earth as the core, which creates this magnetic field. But the core is definitely not the only part of the Earth. There's definitely a lot of different other types of layers. So we have this right here is what the Earth would look like if you were to cut it right down the middle and look at it from the side. We have this outer layer here, the blue and the green part. That's the part we live on. That's called the crust of the Earth. It's got really fine dirt particles that form over really long periods of time from erosion. And it's in a lot of really big, big pieces. And these pieces float on top of this orange layer, which is it's called the upper mantle. The upper mantle is a whole lot hotter than it is up here. It's about 1,800 degrees Fahrenheit, which is hotter than it's ever been on this planet that we know of. And it's made of silicon and aluminum, and there's some iron in there. And it's really thick and putty-like. Try to imagine it like silly putty or something like that. And this bed, this ocean of magma that's underneath us, has these big pieces of crust sitting on top of it that float around. And those big pieces of crust are called tectonic plates. This right here, you may recognize it as the Earth. It is the Earth. You guys are right. And these white lines are the divisions of the tectonic plates. So we have right here, this is North America. This is the continent we live on. And the North American plate is a whole lot bigger than just North America. It does have all of North America in it, but it also has Greenland, a big part of the Atlantic Ocean, all of Cuba, most of Mexico, and a big part of Russia. And that's one gigantic piece of floating crust rock on top of an ocean of magma. And these things move. They move about 1 centimeter, which is probably about that much right there. They move that much every year. So that's not very much, but they're really heavy, so there's a lot of force behind them. The other plate I'm going to talk about is this Pacific plate, which includes, as you guessed, the Pacific Ocean. And it goes all the way down to New Guinea and New Zealand, and then all the way down towards Antarctica over here, all the way around to about halfway through the Pacific Ocean, up the Californian coastline, and then includes just the south of Russia area. And then last and certainly not least is this really small plate right here that my thumb and index finger are pointing at, called the Juan de Fuca plate. Now these 3 plates, they all meet right on the Californian coastline. And if anyone here has ever been to California or knows anything about California, I'm sure you're familiar with the earthquakes that are there and the mountains that are there and the valleys that are there. And this is because those plates, they slide against each other, and when they slide, they'll catch and they'll lurch and they'll cause an earthquake. Or they'll push into each other and they'll push up and build a mountain, or they'll push down and build a big valley. I can answer your question at the end. And these are the geologic activities that create the world and the geologic formations that we're so familiar with and that we see almost every day. Maybe not mountains here in Iowa, but certainly somewhere there are mountains. All right. So I've covered the crust, and the upper mantle. And next, beneath the upper mantle, cleverly named, is the lower mantle. The lower mantle is also really thick, but it's made of heavier minerals called olivine, pyroxene, and feldspar. The average temperature there is about 4,200 degrees Fahrenheit. And these two layers, the upper mantle and the lower mantle, they mix and they churn and they build up pressure. And sometimes they build up enough pressure where they explode out of the crust. Who knows what it is when the mantle explodes out from the crust?
A volcano.
You are right, it's a volcano. And that's how these things happen. Now, interestingly enough, who here knows Yellowstone National Park? All right, seems like a lot of you do. Now, Yellowstone is such a cool place because the crust there is extraordinarily thin, meaning everything is really geologically active. And Yellowstone, believe it or not, is actually one gigantic supervolcano. And within there's about 10,000 years to the past, 10,000 years in the future. That time frame, Yellowstone's going to explode and blow up about 50% of our country. And it can happen anytime, and we don't know when it's going to happen. So, that's pretty cool. Now, to put your mind at ease, though, I'll just talk more about different layers of the Earth. A little farther down, beneath the lower mantle, is the outer core. Now, the outer core, unlike the mantle, is completely liquid. The mantle is kind of putty-like, and the core is liquid. It's a lot hotter. It's about 5,800 degrees Fahrenheit. It's made primarily of iron with a little other parts of metals in it. And it is surrounding the inner core. Now, if you are an astute observer, you've seen that I don't have an inner core. I have a big gaping hole in here. And I need to fill that hole with one of you guys out in the audience. So I'm going to pick you. You. All right. Now I have a hat for you to wear because the inner core is so hot, it's about 8,000 degrees Fahrenheit. So the iron and all the other metals down there are extraordinarily hot, white hot. Didn't mean to cover your eyes. All right. So I'm just going to unroll these layers, the outer layer, which is the crust, the orange layer, which is the upper mantle, the red layer, which is the lower mantle, the white layer, which is the outer core, and then finally, my volunteer, which is the inner core. So I want you to lie down with your head facing towards the audience, right on the edge of the mats. So a little bit farther. Yeah, right there. That's good. So now we begin rolling up our human burrito. All right. So now she's wrapped in the outer core. Next comes the lower mantle, the red layer here, which mixes with the upper mantle, which will sometimes create a volcano, which explodes out of the crust, which is the final layer. Now, a lot of you probably can't see this, so I'll just lift her on up for you guys. So the inner layer, which is the inner core, is surrounded by the outer core, which is surrounded by the lower mantle, which is surrounded by the upper mantle, which is surrounded by the crust. And all of these different layers mix and interact in such a way that life on our planet is able to be alive and create the world that we know and are pretty happy with, as far as I can tell. All right, so thanks for coming up. Let's give her a big round of applause for being so brave. Now wait. Before you sit down, I have two questions for you. Was it hot in there? All right. Well, it's supposed to be. Was it tight in there? Could you move very much? That makes sense. The entire Earth was surrounding you, pushing down. Thanks, you can go ahead and take a seat. Now, one more thing about that inner core. Even though it's 8,000 degrees and even hotter than the outer core, it's actually a solid. It's not a liquid. Even though it's hotter, it's actually turned into a solid because the entire Earth is surrounding on it, pushing down on it so hard that it can't be a liquid. The pressure is so high that it has to be a solid, which means, and the really hot solid is what creates the magnetic field that surrounds our planet and keeps us safe from the sun's rays. All right. So, magnetic fields. Who knows which way does a compass point? Just say it. North, yeah. That's because the magnetic field lines that surround our planet all run from south, out the South Pole, up and around to the North Pole and in. which means that it's strongest, the magnetic field is strongest up at the North Pole. Now, because of this, you guys might be inclined to think that something that is metal up on the North Pole might stick to the ground. So what I'm going to need is a volunteer to come up here. Someone wearing sandals, really easy to remove. You. Yes, you. All right. So these shoes, I need you all to imagine that these shoes are both metallic and on top of the magnetic North Pole, where the magnetic field is the strongest. All right, I need you to slip your feet into those shoes. You can probably leave your sandals on if they're small enough. No, you can't. All right, so if I were to try to, let's say, pick her up where we think the magnetic field is the strongest, you guys might imagine this would happen. I didn't stretch. What was I thinking? You have to stretch before you do exercises. You don't pull muscles and hurt yourself. All right. Ugh. All right. All right. So we all know that if she was actually on the North Pole, even though the magnetic field is the strongest up there, it would actually look like this if she was wearing metal shoes up there. It would not be any problem at all to pick her up because as you get farther and farther away from the source of a magnetic field, it gets weaker quicker and quicker. Meaning when you get the entire distance of the Earth away from the center of the Earth, the magnetic field is not actually all that strong and not enough to hold you to the ground, certainly. All right, you can go take a seat. Thanks for coming up. All right, so what I just told you there is that magnetic fields aren't strong. I need you to forget that because they certainly can be very strong. Who knows what this is? Batteries. It's actually something called an electromagnet, which is a very special type of magnet that you can turn on and then turn off. Notice right now it's off, and it's very easy to pull apart because there's nothing actually holding it together. And then, so these big batteries have these clips on them, which if I connect to the appropriate spots, it'll turn on an electric current, and when an electric current flows around a bunch of wires that are connected in a circle, they create a magnetic field. So now that it's on, it's a little bit harder to pull apart. So I need to demonstrate how hard this is to pull apart, so I'm going to need 4 boys and 4 girls. You, and you in the back in the blue shirt. All right. So you 4 boys stand over there for now. And now the 4 girls, I'll pick you and you in the red hair right there. That's you, yes. You in the black shirt, yes, you. And you in the way back with the glasses and the sparkly shirt, yes, you. All right, so I'm going to start with the boys. Girls, I need you to stand there and watch very closely. Try to learn from their mistakes. See what they do wrong and don't do that. All right, so, oh, you want to prove me wrong? Grab the rope. All right, 2 of you grab the rope here, and then 2 of you come over here and grab this rope. All right, now I'm going, oh, hold on, let go for a second. I need to pull this through right there. All right, now I'm going to hold on to it here in case they do pull it apart. I don't want pieces of metal to fly at your face. All right, you guys want to stand a little bit more like in a line here? So, all right, you want to stand right there? All right. Now let's begin to pull. 3, 2, 1, pull! It's not budging at all. All right. All right, good try. It is very hard. You guys can stop pulling. Thank you. All right, boys, you can stand over there. Girls, did you see what they did? See what they did wrong? Can you do better? Yeah? All right. 2 of you girls come over here. Wait, let's have you go over here because you guys, then the sizes will be a little more equal. And because like these 2 are a little younger, so you just go. This way we won't end up pulling to one side of the stage a whole lot. All right. Because older kids tend to be a little stronger than younger kids. All right. All right. So I want you to pull. On 3, 2, 1, pull. Boys, what are you doing? Now, I didn't pull it apart. What I did do, though, was disconnect the wire. There's no way that you guys could pull it apart. In fact, if I were to, I could probably take all of the kids and have half of them grab one rope and half grab the other, and they couldn't pull it apart. I could probably tie this to my car and tie the other end to another car, and it probably wouldn't pull apart. This electromagnet is extraordinarily strong because it has a large surface area and a powerful magnetic field. Electromagnets, as they can get even stronger. The more electricity you run through it, the stronger it gets, which is why in car impound lots and car destruction lots, they use them to pick up entire cars. So these things certainly can be very strong. I'm just trying to get across that magnetic fields can both be very weak and very, very strong, depending on what type of magnet you're using. All right, thank you guys. I know I cheated. Yeah. You guys can go take a seat. Everyone give them a big round of applause. I am. I cheated. Okay, everyone. Awesome. I'm so happy you got to use that. All right. So earlier, I made mention of volcanoes. Now, there are two main volcanoes that you would see in nature. There's the type of volcano that explodes violently and destroys everything. Think Mount St. Helens or Yellowstone or something like that. The type of volcano that explosively erupts. And then there's the type of volcano that kind of just flows out lava. These are the types of volcanoes that help build islands like Hawaii, which, although very volcanically active, it's more of a passive flow that slowly builds up the rock as opposed to just blowing everything up into the sky. So this right here, this chemical in this tube, is called hydrogen peroxide. A lot of you probably have this in your house. It's a really useful disinfectant. It's a teeth whitener. It's a good cleaning agent. And household hydrogen peroxide is about 5% hydrogen peroxide. This is about 20%, so it's a lot stronger than what you have in your house. And I'm going to pour it in here, and nothing's going to happen because there's nothing in that bottle right now. This right here is your standard run-of-the-mill red food coloring. That's because lava's red, and it's way cooler if I make it red, isn't it? Yeah. This is dish detergent, because volcanoes are bubbly, and they have kind of, bubbles of lava in them. So we got to add some bubbliness, I think. All right, and then I'm going to give it one really good swirl, mix everything up nicely. And then this bottle, which I'm shaking up because it turns into really big crystals that I need to spread apart. Not baking soda, it's actually called potassium iodide. And if you eat it, you'll die because it's poison. But don't worry, because I'm not going to let you eat it. What I am going to do is pour some of this into there. Well, I don't need to do it. I've done this before. I think one of you guys should get to do it, right? Yeah? I'll pick you with the blue hair. Okay. So what I could do is I could just have him pour it in, and you guys would be pretty impressed, and it'd be cool. Or I could add a little more fanfare, and we could give him a big countdown. So what I'm going to need is I'm going to need a countdown from 5, and then you're going to pour this white powder into the top of this right here. So 5, 4,
3, 2, 1.
All right, now step to the side so everyone can see as the volcano begins to flow. And flow. And continue flowing. And steam and bubble. You absolutely cannot touch this. This is something, it's a very basic chemical, which is the exact opposite of an acid. If I were to touch this, my skin would turn white and dissolve. And it would hurt a lot. So don't touch this. Piece of advice. I touched the bag. Very different. And I've done this a lot, so I'm very used to how to act around it. In general, a little note of lab safety. Things in labs can oftentimes be poisonous or bad for you in one way or another. So never eat anything in a lab. Never touch anything in a lab unless you're wearing gloves or you know exactly what it is. And don't mix random chemicals together because you don't know what's going to happen. You could create mustard gas, and that's bad. Okay, so this is still going, just giving you an idea of how much power can be behind a volcano and what type of building action could occur. Imagine this happening if the volcano was actual size and it was building an island. This is what it would look like if you let it go for a very long period of time. All right. So thank you, by the way. You can go ahead and take a seat. Why don't you give a big round of applause, by the way? So this right here is, in fact, helium. I heard that word a good number of times. And this right here is a balloon. Now, I'm sure you all have seen helium balloons before, but this is a very special type of balloon. As soon as you recognize what this balloon is, I want you to scream it out as loud as you can. Yes, it is in fact the Earth. Except I think that this balloon belongs to someone in this audience. Now, I must say that this person in the audience, I saw them and immediately knew that this person is the one who gets to get the balloon. This person is extraordinarily helpful, is a very effective leader, and is responsible for me being here today. It's the director of this library. So what, or librarian lady, I need you to come up here and claim your Earth balloon as a prize for having me here today. Okay, so that's the Earth, and this was the volcano that flows. But I thought I talked about a volcano that explodes, right?
Yeah.
Right. Now, I would do that volcano right here, except it would be very messy, and it would not come out of the walls and ceiling. So we're going to have to go outside in a moment, and we're going to set off a very large baking soda and vinegar volcano. Now, a forewarning. Guys, one thing to say. All right, this volcano will get you guys wet, and you will be left with this white powder on your clothes, and it may look like it's stained, but it washes out really easy in the laundry. You parents have nothing to worry about. Your kids might smell like vinegar, though, so don't breathe in their smell. All right. You three, I need you to help carry stuff. Good? I don't have anything else to carry, sorry. Thanks, though. All right, so I'm going to go out first, and I need all of you guys to follow me. You three, come right behind me. Excuse me. So I'll pour in the vinegar. All right, well, I'll start adding the baking soda to my tube then. I slide this out and then it all can drop in at once as opposed to me pouring in the vinegar. It allows like a quick release system so I can fill it all, get it all in right away. I'm not going to because the camera's there and I don't want to get the camera wet. Sorry.
Are you ready back here? We're taking.
I think he's going to spray it over here.
Are you aiming it?
Okay, so before I do this, I should get a countdown down from 10, 9,
8, 7, 6, 5, 4,
Oh, it didn't come out. Oh, well. All right, so that's all I have for you guys. Thanks for being such a great audience. I hope you have a really nice rest of your day. Give yourself a big round of applause. That's just baking soda. Hi, my name is Neil with MadSci. Thanks for watching. Visit us at madscience.org.